I'm Jake, aka HamStuff, and I've always been of the opinion that volcanoes are pretty cool. Space volcanoes, on the other hand, are out of this world. Loki Patera, on everyone's favourite moon of Jupiter, Io, the most volcanically active body in the solar system. Given what I've seen in pictures, I think this is it. NASA apparently has a live stream of Io. Sure, why not? Anyway, because of the elliptical orbit of Io and the incredible gravity of Jupiter, as it gets further away and closer, its surface, in fact, the whole moon squashed together and extended, with an incredible amount of friction, which produces enough heat to melt rock. And when you have enough heat to melt rock, that heat wants to emerge at the surface in the form of a volcano. So, 10 things to know about Io, according to Solar System Exploration from NASA. It's small, not tiny. Io is slightly larger than Earth's moon, about 1/4 the diameter of Earth itself. And the same side of it always faces Jupiter. I didn't know that. It takes 1.8 Earth days to rotate. It's the most volcanically active world in the solar system. It actually has an atmosphere. I didn't know that. So, 10 need to know things about Io. It's actually slightly larger than Earth's moon. I thought it was quite small. And 1/4 the diameter of Earth. It obviously orbits Jupiter, we already know that. It's 484 million miles away from the Sun. Whereas Earth is 93 million miles away. It's gravitationally tamed. It's actually tidally locked. The same face of Io always faces Jupiter. That's what I didn't know. Volcanically active world. The atmosphere. So, I can't harbour life as we know it, but it could support life as we don't know it. So it's life, Jim, but not as we know it. So volcanoes are sometimes so powerful they're seen with large telescopes on Earth. I think the way they discovered the volcanism on Earth was with the Voyager probes. We were pretty sure about all the moons of Jupiter at this point. It seemed to be a moon emerging from behind Io, which didn't make sense. We would have seen it before. This massive plume, this volcanic plume, was responsible. That was what we saw on the telescope, and it was so large due to the low gravity of the moon. It just goes high and spreads out. We thought it was another moon. Turns out it was a volcano. But yeah, that's a photograph taken from the New Horizons space probe. That's exploring everyone's favourite planet, Pluto. Two big volcanic plumes shooting up. What else can we find about Loki Patera? So, we know that Loki Patera is a volcano because it has lava. And we know it has lava because it has a lava lake. You've seen waves in the lava lake. So it's taking advantage of a rare orbital alignment between two of Jupiter's moons, Io and Europa. Researchers have been able to make an exceptionally detailed map of the largest lava lake on Io. This lake is called Loki Patera. On the 8th of March 2015, Europa passed in front of Io, gradually blocking out Io's light. The event enabled researchers to isolate the heat emanating from Io's active volcanoes. The infrared heat data showed that the surface temperature of the lava lake, I should say Loki surely rather than Loke, Patera, steadily increased from one end to the other, suggesting that lava had overturned in two waves that stretched from west to east at about 1 kilometre per day. A lot more of what I've already said. Most about the moon, that's probably our moon. This is the image of it. It's not exactly what you call high definition. But I suppose if you're a scientist, you can make a lot with that data. I mean, this is more about how they worked everything else and about the observation, but this What I want is simulation of the two-phase resurfacing. So this is the lava lake of Loki Patera. Where it says days, that mostly means days for the moon rather than Earth days. Or it might have been Earth days, I don't know. On Earth, it's easy to define a day. When you say days relating to another planet. So, what does this resurfacing mean? Well, it's also known as crustal foundering. And there was somebody's resurfacing on the small lava pond in Hanimama, which is the summit crater of Earth's most active volcano, Kilauea. So if you were hovering above Io, it would probably look quite a lot like this. Except with less wind, because Earth's atmosphere is a lot thicker. So I don't know why crustal foundering happens. I saw it, the current eruption in Iceland. I saw an area of lava. It's like a big lava pond. And the same thing happened now. It was a fantastic view at it. But it was more than a week ago at this point, I'm sure, on a live stream that's been going for ages. You know, a big crater collapse that's very dramatic. Crustal foundering like this, well, I think it's interesting. But it doesn't quite look as dramatic. And then, because it's exposed to the air, which is much cooler, the surface loses enough heat that actually cools. Well, I wouldn't quite call it solid. You wouldn't want to stand on it. But it's no longer producing light. That's why it forms a dark crust of lava. Like the skin on custard, I suppose. Let's take another look without me talking over it. See, one thing I forgot to check. How large is this thing? 127 miles or 200 kilometres across. You will notice there's an island in the middle. Well, I suppose peninsula since it's connected to the inside. After the, I think, was it 2020? The first time Kilauea erupted in more than 2 years at that point. They did form an island, although there was previously a water lake in Hanimama, atop Kilauea. I doubt that's true for the surface of Io. When you think of large volcanoes on Earth, you probably think of Yellowstone. Oh, Mauna Loa, the big island of fire. But Yellowstone is overhyped. Mauna Loa is dwarfed by Olympus Mons on everyone's favourite red planet. Now, Mauna Loa is a very large volcano, but it's 120 kilometres long and 103 kilometres wide. I believe that's from the base. And it's also very, very tall, 17 kilometres. high. I believe that should be tall, since Everest is the highest mountain on Earth, but Mauna Loa is taller. And fun fact, Mauna Kea is 38 metres taller than Mauna Loa. So, a caldera is a depression in the ground formed when a volcano, or part of a volcano, collapses into its own magma chamber. On Mauna Loa, Makuaweo is 6 kilometres long, half that wide. Here we are, Yellowstone. 80 kilometres long, 65 kilometres wide. Because it's a big hole in the ground, it's not particularly tall. So how big is Olympus Mons? I mean, there's its height compared to Everest, the aforementioned Mauna Kea, and this is Olympus Mons on Mars. Now, if you look at it here, there are what seems to be cliffs. Some steeper than others, sure. But it seems that the big island of Hawaii is not that big at all compared to how large the former island, because it was believed Mars had oceans, the island of Olympus Mons. In fact, here's a good diagram. This is it compared to France. So it's about as wide as France. Alright, zoom out. I'll go this way. Start new. I believe it's roughly from there to there. So 777 kilometres. It's about the size of France, which is about as large. Do I have enough tabs open? My goodness. As Olympus Mons. Premium AI image. I'll pass if you don't mind. Now, as it's roughly the shape of Captain America's shield, you can probably tell it's a shield volcano, formed by successive eruptions of low viscosity lava known as basalt. So this is what NASA will have to say about it. So much like everyone's favourite supervolcano, Yellowstone, and the volcanoes of the big island of Hawaii, such as Mauna Loa, each of those and Mauna Loa are believed to have been generated by a mantle plume, an upwelling of hot, more fluid material in the mantle. Now, because Yellowstone and Hawaii each have a hot spot, people think they're somehow related and that one could cause the other to erupt. That's not it at all. They're really far apart on different areas of the planet. They're an ocean away. It's just the same mechanism that formed them and Mauna Loa. Whereas there are a chain of calderas across the United States that shows the path of the tectonic plate, the North American plate, over this hotspot, which is the area on the surface, above the mantle plume. And Hawaii has its chain of islands. The Hawaii Emperor Sea Mat chain might be the longest volcanic range in the world, or at least in the oceans. I'm not sure on that. You have to fact check it. Mars, on the other hand, is believed not to have tectonic plates, so it wouldn't have moved compared to the hotspot. So on it, I wish I could drag the whole image as the size it is, but the hotspot would remain here for perhaps millions of years, always erupting in this area, building up a mountain of truly colossal size. So its eruption is thought to have been last eruptions believed to have been 25 million years ago. So it's 3 times higher than Everest. Well, high in respect to what? I'm 6'2", but I'm a lot higher than that right now, because I'm on a chair in my bedroom on the first floor of my house. If someone was standing next to me who's taller than me, I could still be higher if I'm standing on a chair. So Everest is only the highest mountain on Earth. It's not by any means the tallest. In any case, you could probably stack both on top of one another and not reach the height of Mauna Loa. Not Mauna Loa, Olympus Mons. So Olympus Mons is how tall? Olympus Mons is a big volcano. It is almost unimaginably huge. It's 550 kilometers across at its base. Okay, so I estimated it a bit more than that. And it's pretty circular, but I suppose I don't know. I'm not going to try and reason more into saying I was right. But 550 kilometers wide, very big. The volcanic crater, the technical term is caldera, at its peak is 80 kilometers long. If you were standing at the edge of the caldera, the volcano is so broad and the slopes of it are so gradual with the base of the volcano beyond the horizon. That's right, it is a volcano so big that it curves with the surface of the planet. I mean, doesn't everything? And it is tall, 27 kilometers tall, 16.7 miles from base to summit. 3 times as tall as Mount Everest, even Mauna Kea, Earth's own giant shield volcano, doesn't come close. Measured from the seafloor to its summit, Mauna Kea is taller than Everest, but only 40% the height of Olympus Mons. Here's another thing, I'll highlight the text. Olympus Mons is so tall that it sticks up out of Mars' atmosphere. The atmosphere of Mars is thin to begin with, but at the summit of Olympus Mons is only 80% of the normal Martian atmospheric pressure. Finally, since it is fun to compare Olympus Mons to Mauna Kea, what would the pressure be like at the summit if we placed Olympus Mons next to Mauna Kea in the Pacific? In that case, the summit of Olympus would be 21 kilometers, if I could English today, above sea level, still higher than Everest, and about twice as high as normal jets fly. The atmospheric pressure at the summit would be about 4.6 that at sea level. For comparison, the top of Everest is about 1/3 the pressure at sea level, and most people still need to use their oxygen canisters. What else do we have on Olympus Mons? Okay, NASA, I believe, receives 4% of the OS's government budget every year. Not 1/4 or a quarter as people often believe. Perhaps it's better they receive close to that second number because this looks like it was printed in 1997. The largest of the volcanoes in the Tharsis Montes region, as well as all known volcanoes in the solar system, is Olympus Mons. Olympus Mons is a shield volcano, 624 kilometers in diameter. That is more than the number I just got. So maybe it's not perfectly circular, or at least as circular as it looks. About the same size as the state of Arizona. If that means anything to you, if you live in Arizona, almost certainly. If you don't, probably not. Well, why is Olympus Mons so big? The main difference between the volcanoes on Mars and Earth is their size. Volcanoes in the Tharsis region of Mars are 10 to 100 times larger than those anywhere on Earth. The lava flows on the Martian surface are observed to be much longer, probably a result of higher eruption rates and lower surface gravity. Another reason why the volcanoes on Mars are so massive is because the crust on Mars doesn't move the way it does on Earth. On Earth, the hot spots remain stationary, but crustal plates are moving above them. The Hawaiian Islands result from the northwesterly movement of the Pacific Plate over a stationary hotspot producing lava. As the plate moves over the hotspot, new volcanoes are formed and the existing ones become extinct. This distributes the total volume of lava among many volcanoes rather than one large volcano. On Mars, the crust remains stationary and the lava piles up in one very large volcano. 3D image of Olympus Mons will need 3D glasses. What else do we have on Olympus Mons? Around its perimeter, an outward-facing cliff ascends as high as 10 kilometers above the surrounding area. At the summit, 80-kilometer caldera. Water ice clouds are visible. Mars has clouds? Well, I do believe that's all we have about Olympus Mons. Now, somewhere you might not expect to have volcanoes. If I were to make a list of things you'd expect to find on Mars, you might expect it features things like rocks, American flags, old spacecraft from NASA, a car on the moon. What else? What else? Craters, Captain America, Nazi base maybe, the Clangers, although they don't live on the moon. I always thought they did. Turns out they're somewhere else, across the myriad stars of the firmament. Whether that means, but you probably wouldn't expect to find volcanoes. Although the moon isn't somewhere you typically expect to find volcanoes, there might be more of them than you think. So, a scientific look at volcanoes on the moon. How recently has a volcano eruption occurred on the moon, and how much do we know about its volcanic past? Only a few decades ago, there were two schools of thought about the origin of lunar craters, crater Tycho and crater Copernicus. Many astronomers believed them to be of internal origin, say volcanic, quite different from our own towering volcanoes such as Vesuvius, and more akin to a caldera, such as those found in Hawaii. Those are sure volcanoes, though. They have calderas, but Vesuvius has an enormous caldera. It's growing out of a caldera. But anyway, the rival theory attributed them to meteorite impacts. Whoever was writing this says, I was a strong supporter of the volcanic theory, but the evidence against it built up until even die-hards like myself had no choice to admit that it was wrong. It now seems definite that the moon was formed 4.6 billion years ago by a collision between a proto-Earth and a body roughly the size of Mars. The heat generated during the formation melted the outer layers down to a depth of several hundred kilometers. The less dense material separated out to the surface and produced a crust. Then, between 4.4 and 4 billion years ago, came the late heavy bombardment, when meteorites rained down to produce the oldest basins, still miscalled seas. Why miscalled? The Iridium Basin dates back perhaps 3.85 billion years. After the Great Bombardment ceased, there was widespread volcanism, with magma pouring out from below the crust and flooding the basins, produced structures such as the Mare Orientale. I guess that's that then. The lava flow ceased rather suddenly by cosmic standards, and for at least 1 billion years the moon has seen very little activity. The gravitational pull is much less than ours, so there's no air. Virtually any air atmosphere on the moon may have once had has leaked away into space. And there's no water either. Okay. The lunar lavas are basaltic. We know very few discrete features that can be described as volcanic in the usual sense of the term, and all of these are very small. A team led by Bradley Jolliffe from Washington University in St. Louis, Missouri, found evidence of volcanoes on the moon's far side. Using images from the Lunar Reconnaissance Orbiter, Jolliffe studied a curious hotspot between two ancient impact craters, Compton and Belkovich, in the moon's North Pole area. The hotspot seemed to be a small volcanic province created by the swelling of silicon-rich magma, usually linked with explosive volcanism. It is officially known as the Compton-Belkovich thorium anomaly because the rocks are rich in the heavy radioactive element thorium. So they're out of your Earth, beyond the limb of the... I'm not going to try and read that. It's midnight and I'm tired. The angle of the sun can fool the brain to seeing domes as craters and vice versa. I mean, I'm seeing these as craters. I'm seeing that as a dome. And that as a crater. So this area contains numerous domes, some of them more than 6 kilometers high, with steep sloping sides, which are apparently formed from viscous lava. There are also circular depressions, presumably resulting from caldera collapse or volcanic vents. So these rocks are very different from the basaltic lava making up the lunar seas, and are higher in silicon and potassium. So it was thought it's been over 1 billion years since there was volcanic activity, but this is the first evidence of such young volcanic activity on the Earth's surface. It was still geologically active 800 million years ago, rather than 1 to 2 billion years. Any signs of activity on the moon at the present moment? Young volcanoes on the moon. Irregular mare patches. Interesting. Is that what the volcanoes are called? So, what exactly are these irregular mare patches? Areas seem to be the aftermath of a volcanic eruption. But it said somewhere. Some of the images they found are lightly cratered, no more than 100 million years old. Some of the volcanic features may be 50 million years old. Wow. So after the extinction of the dinosaurs. It teaches us the interior of the moon is perhaps hotter than previously thought. I mean, a large impact would probably melt the rock beneath it, some of which could erupt afterwards. So, focused mostly on basaltic magma, but there was a huge granite body on the far side of the moon, offers clues to ancient lunar volcanoes. A large formation of granite, the same type of magma under Yellowstone, discovered beneath an ancient lunar volcano, is further evidence that the far side of the moon once glowed with volcanic eruptions. The granite was found on a suspected volcanic feature on the surface of the moon called Compton Belkovich. This feature was likely formed as a result of cooling magma that led to fire eruptions of lunar volcanoes about 3.5 billion years ago. Finding the remains of volcanic activity in this region of the moon isn't completely unexpected, as researchers have long suspected this area to be an ancient complex of volcanoes. What has come as a surprise to the team, however, is just how large this patch of cooled magma is. With an estimated width of 31 miles or 50 kilometres, the discovery of this large body of granite beneath the Compton Belkovich volcanic complex could help scientists explain how the lunar crust was formed in the moon's early history. So magma doesn't always reach the surface. About 9 out of 10 magma intrusions on Earth don't reach the surface. Batholiths are much bigger than the volcanoes they feed on the surface. For example, the Sierra Nevada mountains are a batholith left from a volcanic chain in the western United States that existed long ago. I'd recommend giving a Google to Nick Zentner, Ghost Volcanoes. He's got a lecture about that. I find it very interesting. The formation of granite on Earth is usually the result of water and plate tectonics creating large areas of melted rock that are called melt bodies beneath the planet's surface. Though common on Earth, granites are much scarcer on the moon as a result of the absence of both water and plate tectonics. That means that the discovery could point towards the conditions locally or globally found on the moon when there is a host of volcanic activity. If you don't have water, it takes extreme situations to make granite, Ziegler said. This article mentioned Ziegler before, but I don't know who they are, but let's listen to them. So here's a system with no water, no plate tectonics, but you have granite. Was there water on the moon, at least in this one spot? Or was it just especially hot? But it certainly appears that there's no evidence of current volcanic activity on the moon. There certainly was in its history. So I've just discovered I was a little too close to the camera for most of that. I'm not going to re-record because I'm very tired and it's midnight. But it's not just the Earth that has volcanoes. Mars and even our moon have had in the past volcanic activity. And I just want to mention Venus definitely has volcanoes. We don't know if they're currently active, but there have been large spikes in the amount of sulfur dioxide, which on Earth, the only natural process that generates that is volcanoes. And Pluto, everyone's favourite 9th planet of the solar system, has cryovolcanoes, where ice erupts instead of lava. But those are somewhat mysterious in how they work, because lava, molten rock expands as it's hotter, as with a lot of fluids, and then it shrinks when it cools. And it's also very gas rich, and so it's buoyant compared to the material in the mantle it surrounds itself with. So that also helps. But ice expands. Frozen water is less dense than liquid water. So you wouldn't expect liquid water to come out of a volcano made of ice. And you wouldn't expect ice to come up either, because ice is typically solid. What's thought to happen here is something to do with ammonia. Quite what, I don't really know. But I just want to briefly mention those two things and say thanks for watching. Please like and subscribe.